Dragging and moving an icon on a desktop. December 27, 2022. This is a minimal reproducible Java program that I have created today, which is a simulation of dragging and moving the icon my computer on a Windows 95 desktop. After watching the drag and drop episode of Java Full Course by Brocode, I managed to apply the knowledge gained from watching this tutorial, and rework the code snippet shown in the tutorial to incorporate it in the most complicated Java program that I have created, namely Windows 95 Simulator. Nevertheless, the code snippet of the minimal reproducible program is based on a tiny portion of the tremendous amounts of code my Windows 95 Simulator. As it is presumably impractical to incorporate the tremendous amounts of code of my Windows 95 Simulator in a single article, I created the following code snippet from scratch to generate a minimal reproducible example. Besides, the concepts of point, MouseAdapter and MouseMotionAdapter are involved in the code snippet of this program. In the following paragraphs, I am going to expound the syntactic details of this program as well as these concepts. In the beginning of the code snippet of this minimal reproducible program, 2 classes in java.hot package, 3 classes in java.odd.event package, and 4 classes in javax.swing package were imported. After typing public class, I type the name of the public class drag and move my computer, followed by an opening curly bracket, after which method main was defined. In the body of method main, I invoke the default constructor of the public class by typing the new keyword, followed by the name of the public class, a pair of parentheses, and a semicolon. Then, I completed the body of method main by typing a closing curly bracket. It should be noted that upon invoking the default constructor of the public class by using the new keyword, there is no further need to create a new class for this purpose, which means that it is possible to include the entire code snippet in a single public class and its class constructor. After the closing curly bracket of method main, I declared a point object named my computer previous point without instantiating it. Then I created a class constructor by typing the name of the public class, a pair of parentheses, and an opening curly bracket, after which I typed the rest of the entire code snippet. Next, I am going to expound the syntactic details of rest of the entire code snippet in the class constructor. In the beginning of the class constructor, I instantiated a color object and assigned a RGB value 0, 130, 130 to this color object. This particular RGB value is equivalent to teal blue of the Windows 95 desktop. It is possible to obtain any RGB value by pressing PRTSC button on the keyboard and clicking paste in Microsoft Paint, using color picker to obtain any selected color, and then using edit color to obtain its RGB value. After instantiating the color object, I instantiated a desktop pane object named desktop, and set its background color to teal blue defined with the color object. Using the setLayoutNull method, I set the layout manager to null for the desktop pane object. Next, I instantiated a global object named my computer. After the global object was instantiated, I instantiated an image icon object within the pair of parentheses, in which I typed the name and the extension of the PNG image file bracketed by double quotes. Then, using the setBounce method, I moved and resized the global object. It should be noted that when setting the x and y coordinates, width and height of the component in a container, in order for the component to be properly displayed, the setBounce method should be used together with the setLayoutNull method. Some discourage setting the layout manager to null for a container, but the setLayoutNull method should be used when absolute positioning is necessary. Then, using the add method, I appended the global object to the desktop pane object. Thus, it could be considered that the global object acts as a component, but the desktop pane object acts as a container. Next, I instantiated another point object named my computer start point, and set both the x and y coordinates of the newly constructed point to 0. Then, I added mouse listener to the global object to receive a specific mouse event from this component, using an abstract adapter class called MouseAdapter. I found out that the fundamental difference between a listener and its corresponding adapter is that all the inherited abstract methods must be implemented in a listener, but it is permitted to implement any number of inherited abstract methods in its corresponding adapter. Since it is necessary to implement only the mouse pressed method, I passed MouseAdapter to add mouse listening method as its parameter. Within the mouse pressed method, I assigned the x, y position of the MouseAdapter relative to my computer previous point, using the getPoint method. It should be noted that the getPoint method is invoked for the instance of mouse event, denoted by the letter E by default. After adding mouse motion listener to the global object and passing MouseMotionAdapter as its parameter, I implemented the mouseDragged method, in which I instantiated another point object named myComputerCurrentPoint, and assigned the x, y position of the MouseMotionAdapter to myComputerCurrentPoint, using the getPoint method. Next, the most crucial part to simulating dragging and moving an icon on a desktop is to type the name of the point object in which x and y coordinates of the newly constructed point were set to 0, namely myComputerStartPoint, and then invoke the translate method, which is used for translating a point object at the location of x and y coordinates, by the distance to move this point object along the x-axis, and by the distance to move the point object along the y-axis. Regarding the parameters passed to the translate method, the first parameter should be a result of difference obtained from subtracting the x-coordinate returned of myComputerPreviousPoint from the x-coordinate returned of myComputerCurrentPoint, whereas the second parameter should be a result of difference obtained from subtracting the y-coordinate returned of myComputerPreviousPoint from the y-coordinate returned of myComputerCurrentPoint. Besides, typing casting from double to int should be performed for both parameters, because both the getX and the getY methods return their respective coordinates of the point object in double precision. It should be noted that not only the data type that needs to be casted into should be bracketed by double quotes, but also the getX method and getY method should be bracketed by double quotes. After implementing the translate method, I moved and resized the global object by setting its x-coordinate to the x-coordinate returned of myComputerStartPoint, its y-coordinate to the y-coordinate returned of myComputerStartPoint, without altering the width or height of the global object. Using the revalidate method, it is possible to support the deferred automatic layout. Using the repaint method, it is possible to repaint the desktop pane object. Nevertheless, without using these two methods, I notice no difference in the output of the program. After I finished typing the blocks of code for both addMouseListener and addMouseMotionListening methods, I instantiated a frame object named mainFrame and set its title to drag and move my computer by typing the string literal bracketed by double quote within the pair of parentheses after the frame object was instantiated. Then, using add method, I appended the desktop pane object to the frame object. Thus, it could be considered that the desktop pane object acts as a component, and the frame object acts as a container. Next, using setExtendedState method, I set the state of the frame by passing the state bit masked_frame.maximized_ both as its parameter. Using this method, it is possible to fully maximize the frame object without using the setBounds or the setSize methods. Lastly, it is essential to remember to use the setVisibleTrue method to display the frame object when the program compiles and runs. Regarding the entire code snippet of this program, one particular detail that I would like to discuss is that I did not instantiate myComputerPreviousPoint within the class constructor. This is because I found out that it is necessary to invoke myComputerPreviousPoint within both MousePressed and MouseDragged methods. I also found out that declaring myComputerPreviousPoint within the class constructor would result in the appearance of a red underline beneath myComputerPreviousPoint within the MousePressed method. A tooltip message: local variable myComputerPreviousPoint defined in an enclosing scope must be final or effectively final is displayed when the mouse cursor is hovered over the red underline myComputerPreviousPoint within the MousePressed method. If the final keyword is typed before myComputerPreviousPoint, the red underline does not disappear, but a tooltip message: the final local variable myComputerPreviousPoint cannot be assigned, since it is defined in an enclosing type is displayed when the mouse cursor is hovered over the red underline myComputerPreviousPoint within the MousePressed method. In order to resolve this issue, I found out that it was convenient to create a class constructor, and then declare myComputerPreviousPoint before and outside the class constructor without instantiating this point object. It should be noted that myComputerPreviousPoint is the only object that needs to be declared before and outside the constructor without being instantiated, because it is used within both the MousePressed and the MouseDragged methods. Regarding this program in particular, I have successfully worked out the code snippet for achieving 1 out of 3 results that I expected to achieve. The first result that I have already achieved is, upon clicking the icon, if either mouse button is held down and the mouse is moved, then the icon is relocated instantly to the position of the cursor. The second result, which I expected to achieve, is, upon clicking the icon, if the left mouse button is held down and the mouse is moved, a shadow of this icon appears along the trajectory of the cursor, but not relocated to the position of the cursor until the left mouse button is released. The third result, which I expected to achieve, is, upon clicking the icon, if the right mouse button is held down and the mouse is moved, a shadow of this icon appears along the trajectory of the cursor, but a pop-up menu containing Create Shortcut and Cancel does not appear until the right mouse button is released. I do not know how to create such a shadow of the icon. In order to acquire such knowledge, I have posted a relevant question on Stack Overflow, but unfortunately as of this writing, no user has provided any answer or comment to this question. In contrast to the sample code shown in Brocode's drag and drop episode, I did not create any additional public class to inherit either of the abstract adapter classes. In my opinion, it is unnecessary to inherit any abstract adapter class using the extends keyword, since it is permitted to implement the inherited abstract method directly within MouseEvent. Besides, I found out that the code snippet of this program still works without the paint component graphics G method, which can be implemented in each panel object, but cannot be implemented in each frame object. Furthermore, simulating the functionality of dragging and moving any icon on the desktop has been a crucial aspect to the development of my Windows 95 simulator. With a caveat, I made multiple attempts to export my Windows 95 simulator into a runnable jar file, and convert the jar file into an executable file, but the executable file does not run when clicked. I have not yet found the underlying cause for the unresponsiveness of the executable file. Additionally, in my opinion, this program is a good practice for intermediate programmers with a little programming experience, as the concept of point is involved in this program. The key points of this program are summarized below. Key points, / denoting the user-defined name of the instance of MouseEvent / denoting the user-defined name of the global object / denoting the user-defined name of the point object. Add mouse listener new MouseAdapter, public void mouse pressed MouseEvent. Add mouse motion listener new MouseMotionAdapter, public void mouse dragged MouseEvent. Point equals new point x, y, point equals. Get point translate, end. Getx. Getx, end. Getty, set bounds, end. Getx, end. Getty, width, height. Import java.hot.color. Import java.hot.point. Import java.hot.event.mouseAdapter. Import java.hot.event.mouseEvent. Import java.hot.event.mouseMotionAdapter. Import javx.swing.image Import javx.swing.stop Import javx.swing.frame. Import javx.swing.global. Public class drag and move my computer. Public static void main string. Args. New drag and move my computer. Point my computer previous point. Drag and move my computer. Color teal equals new color 0, 130, 130. Desktop pane. Desktop equals new desktop pane. Desktop.set background teal. Desktop.set layout null. Global my computer equals new global new image icon my computer.png. My computer.set bounds 2, 0, 102. 77. Desktop.add my computer. Point my computer start point equals new point 0, 0. My computer.add mouse listener new MouseAdapter, public void mouse pressed MouseEvent t. My computer previous point equals e.get point. My computer.add mouse motion listener new MouseMotionAdapter, public void mouse dragged MouseEvent t. Point my computer current point equals e.get point. My computer start point translate, end. My computer current point.getx, my computer previous point.getx, int my computer current point.getty, my computer previous point.getty, my computer.set bounds, int, my computer start point.getx, int my computer start point.getty, 102, 77. Desktop.revalidate. Desktop.repaint. Frame mainframe equals new frame drag and move my computer. Mainframe.add desktop. Mainframe.set extended stage frame.maximized underscore both. Mainframe.set visible true.